If you don't like the approach of using factory methods in order to construct classes which need to be initialized asynchronously, there is a different way. What you can do is you can simply introduce an interface for indicating that some of your classes require asynchronous initialization, and then you can detect this interface and perform additional operations if in fact this interface is detected. And this gives us the asynchronous initialization pattern. So basically what you have is you have some interface like iasync init, and this is the interface you would use to indicate that some class requires asynchronous initialization. Here you would store the task. So here you would have a property getter for the initialization task itself. So that would be the task that initializes the class, and this task would obviously be subject to an await at some point, and then you can build your class. So here we can have a class called myClass. We can implement the iasync init interface and implement simply this task. Then we can have a constructor. So let's build a constructor here. Now, I won't fill in the constructor just yet because we have to fill in the asynchronous initialization method. So here we'll have a private async task init async. So this is a private method that will be called to asynchronously initialize the class. Here you can await something, let's say task.delay 1000. This is just a simulation, so we're not going to do anything here. And then finally, what you do in the constructor is you initialize the task variable, or the property rather. So you say init task equals init async. So that's it. This is how you actually store the variable, and then of course you have to await it when you come to use the class. So here, if you make a new instance of my class, so if I say new my class and I make a variable out of it, what I need to be able to do is I need to be able to detect that this class implements iasync result. So I would say something like, if my class is iasync result AI, for example, then I would say AI.task init task, and I would await this task to ensure that the class is actually initialized. So this is somewhat better, and it actually allows you to perform composition of these classes, because let's imagine if you have yet another class. So we'll have another class called my other class, which is actually, let's just copy and paste the one that we have up above. So if I copy this class over and just paste it once again, so I'll call this my other class, and this would also be in the constructor. Now let's imagine that my other class depends on my class. So here we have a private read-only my class, and let's suppose that we actually initialize this field in the constructor like so. Then what you would have to do when it comes to asynchronously initializing this particular class is you also have to wait for dependence. So before performing your own initialization, you have to go through every single property or field you have that is of a type iasync result, and you would have to once again await its task. So here I would say if my class is iasync result AI, then I would say await AI.init task. Unfortunately, it's rather difficult to sort of do this automatically, in the sense of having the code detect every single field that implements iasync init and then await on that. So you have to do it by hand. But once you're done, you can continue just awaiting whatever operations are core to the current class, and then this whole thing composes just fine. So you can write something like the following. So here you can say, for example, var oc equals new my other class. You simply pass my class as a constructor argument, and then you await oc.init task, which recursively awaits the initialization tasks of any of the members. So here we pass my class, and it would be awaited right here before the whole thing is kind of finished. So this is the gist of the asynchronous initialization pattern. Once again, this is something that is best used inside the dependency injection container rather than done by hand, because in the dependency injection container, what you can do is you can detect that a particular class has to await initialization, but you still have this problem that if your class has dependencies, then you have to manually go through these dependencies and make sure that they are awaited as well. Alternatively, you can get the DI container to do this automatically for you, but then you get into all sorts of weird ordering effects, and it really depends on the DI container that you're actually using. But this approach also is possible, and it can simplify this asynchronous initialization pattern even further.